let us now proceed with checking the spelling. So in Python, there is another library to check the spelling automatically. So we don't need to go into details about how to correct automatically, but let us just utilize the autocorrect library. So if you're in Jupyter Notebook, so you have to use this library inputs as and then minus and pip install autocorrect. So you can use it automatically. So you check the spelling automatically. So what happens here, I tried encoding around spelling, example this one, and then automatically it checked the spelling with autocorrect. So yeah, we have this word lit and then the word race for the autocorrect. So we also convert all the words into lower. Then the last topic is about stemming or lemmatization. So when you say stemming, you try to identify the stem of the word. So you try to remember that morphemes is the smallest independent unit in any natural language. When we say morphemes, those are consist of units that are stems or affixes. So when you say affixes, you have the suffix, the prefix, and so on. And you try to identify the base of a word. And of course, given the base of the word, you can create another word by adding affixes known as inflections. So we have here an example. The word stem is jump. Then you have some different inflections now. So you have jumps, jumps, and jumping. And these are what we call the suffix. Yeah, suffix. Now, in natural language processing, usually when you try to process the different words, you really have to identify the different stems. So you try to narrow down the very basic form of a word. So we call that one as stemming. So the first algorithm, the first person who created a stemming library is what we call as is Dr. Martin Porter. So we call it as Porter stemming. So automatically you can also use the NLTK framework that stem in order to use stemming. So example of a stemming. So you have the amazing when you try to identify the words. Almost I don't know what happens here with the algorithm. Second library is the Lancaster Stemmer by Christy Pace. And then there are 120 rules. So what happened with Lancaster Stemmer? So when we say running, returns run, runs, return the word run, and ruined, return the word ruin. So when we try to, we already have the tokenized, we already remove in a tokenized form the stop words. So what happens here? We check the spelling, we convert it to lower, we expand the constructions, we try to remove the punctuation, and then we tokenize our text, then remove the stop words, and then what happens here is that tokenize again the new word list, and then now we try to append the stem word. So the quick, so what happens here? Phone, the mask, the language, and then wins. Let's try to look at the original output. So what do we have here? Lot, so it's only the word amazing. So what happens here is when you try to stem, you have the word amas and also the language. Lemmatization, on the other hand, is similar to stemming, but you get the root word. They have the same, but what happens here is that you have to identify the word. So learning, we identify the verb, and then saddest adjective. So it returns the root word learn, and then with salad. I tried to use the amos, but it's a raw lemmatized word. So that's it for today. So you have some textual data uploaded in the in USTEP. You can practice the following in your in the text data given to you. So you check the spelling, you expand the contractions, you remove punctuation, you try to tokenize text, you remove the stop words, and then perform STEM. So you also your laboratory exercises also involves this different text in text normalization. So that's all, and you may message me if you want some clarification and questions about our lesson. Thank you and good morning.